Hello students, welcome to Talk on Civil Engineering. Let us discuss how we can design doubly reinforced beam section. Usually we'll go for WBM doubly reinforced section whenever the depth D is restricted. The overall depth of the beam is restricted, we'll go for the double beam section, as well as when the movements, when you are getting large movements, then we'll go for the doubly reinforced section. That means mu is greater than mu limit. So what is mu limit? Mu limit is a maximum movement that can be allowed on the beam. Okay, so mu is the movement that you are getting because of the loads, right? Or else this mu limit can be also called as mu balance. That means the movement for a balanced section. So the movement that can be allowed for a balanced section. Balanced section ki enta movement allow cheyochu, that is mu limit. Okay, so the bending moment coming on the beam due to the loads, if it is exceeding the balanced movement or limiting movement, then we'll go for the doubly reinforced beam sections. Okay, so remember that. And here if you see here, so this is a total this is how your doubly reinforced beam section will be there. So this, the diagram 1, the first figure represents the doubly reinforced beam section, doubly reinforced beam section, and the second one represents the section for balance. This is a balanced section, we can call it as a balanced section. So I have told you, so whenever the movement is exceeded than the balanced movement or limiting movement, then we'll go for the doubly reinforced section. Okay, so that means, so this is the mu. Okay, so mu is equal to, we can write it as mu limit plus mu additional or excess. Okay, so mu greater than mu limit ఉందంటే దాని అర్థం ఏంటండి? mu greater than mu limit ఉందంటే దాని అర్థం ఏంటి? కొద్ది ఎక్సెస్ మూమెంట్ ఉంది అని. సో ఆ ఎక్సెస్ మూమెంట్ ఎలా అనుకుంటున్నాం అంటే mu minus mu limit చేసాం అనుకోండి, విల్ గెట్ ద ఎక్సెస్ మూమెంట్, రైట్? సో ద అడిషనల్ మూమెంట్ ఆర్ ఎంత ఎక్కువ మూమెంట్ ఉంది ఆ మూమెంట్ ఎలా కనుక్కోవచ్చు? mu minus mu limit. సో దిస్ mu minus mu limit represents this figure. Okay, so that means we are designing a balanced section for a mu limit value ki oka balanced section design chestunnam, like a singly reinforced beam section. Balanced section ante singly reinforced beam section e kada, oka singly reinforced section, and additional movement ki we are providing extra steel. So remember, so ikkada meeru diagram, third diagram meeru chuste, I have drawn the diagram with a dash line. So concrete anta dash line tho draw chesam. That means we are taken concrete completely in second diagram itself. కాంక్రీట్ ఇక్కడ కంప్లీట్ గా కాంక్రీట్ తీసేసుకున్నాను ఈ డయాగ్రామ్ లో. అంటే బ్యాలెన్స్డ్ సెక్షన్ లో mu లిమిట్ కి ఐ హావ్ టేకెన్ కంప్లీట్ కాంక్రీట్ కి ఉన్న స్ట్రెసెస్ అంతా నేను బ్యాలెన్స్ సెక్షన్ లో తీసేసుకున్నాను. ఓకే, అండ్ ఫర్ లిటిల్ బిట్ స్టీల్ ఫర్ ద బ్యాలెన్స్ సెక్షన్. ఓకే, సో ఇన్ ద థర్డ్ సెక్షన్ లో, థర్డ్ ఫిగర్ లో, సో ఐఎమ్ ప్రొవైడింగ్ దిస్ థర్డ్ ఫిగర్ ఫర్ అడిషనల్ మూమెంట్. ఓకే, సో దేర్ నో కాంక్రీట్, అడిషనల్ గా ఎక్స్ట్రా కాంక్రీట్ ఏమి మనం యాడ్ చేయలేం కదా, బికాస్ బ్యాలెన్స్ సెక్షన్ లో అంతా కాంక్రీట్ తీసుకున్నాము. అడిషనల్ గా కాంక్రీట్ ఏం యాడ్ చేయలేం బికాస్ ద సైజెస్ ఆర్ రిస్ట్రిక్టెడ్ హియర్. ఓవరాల్ డెప్త్ అండ్ విడ్త్ is restricted, you can't increase the concrete. So therefore we are providing additional bars to take care of the mu additional. So we are providing additional bars, that's it. That means it's completely only the steel, not concrete. Concrete is not there, only steel is there for additional movement. Okay, remember that. Okay, so the doubly reinforced beam is nothing but is a combination of a singly reinforced section or a balanced section plus other section, other steel section, or like a steel section for additional movement. Okay, so why I'm talking enduku steel section అని అంటున్నాను, బికాస్ కాంక్రీట్ అనేది వీఆర్ నాట్ టేకింగ్ కాంక్రీట్ అసలు లేదు. కాంక్రీట్ తీసుకుంటలేము, ఓన్లీ స్టీల్ బార్స్ తీసుకుంటున్నాం. ఓకే, సో హియర్ look here, so this is, I can call this as AST1 and this as AST2. Okay, so what is AST? Area of steel in tension. Okay, A represents area, S means steel, T means tension. Okay, similarly this is the area of steel where in compression, right? Area of steel in compression. Okay, remember these values. Okay, now let us understand the stress diagram. So from stress diagram you can easily go for the design. If you are able to understand the stress diagram, we can easily go for the design. So for mu limit, mu limit in the sense for a balanced section. So for balanced section, you know how the diagram will be. A straight rectangular portion up to some distance and a parabola up to xu. Okay, so this is xu, and from here to here this is d dash, sorry, effective depth d. Okay, and you know here you will be having c. So this is for mu limit, let us call it as c1, and here you will have t1. Okay, for additional moment you don't have any concrete, so let us draw a straight line which represents only steel, and here you will have t2, and somewhere here at the level of compression steel. I'm trying to draw a section. Okay, so here you have a compression steel and here you are having a tension steel, right? So this compression steel is provided at a distance of d dash. So d dash is nothing but is an effective cover, that's it. Effective cover, the same cover, same tension ki effective cover ela provide chesamo, compression steel kuda alane effective cover provide chesam. So this is at d dash, so let us call it as c2. Okay, and you know this is at 0.42 of xu, and this value is, so this is a stress parameters you already know, even in the code book also you are having. So this is 0.45 fck, yes, right? And what are the value of c1? C1 is equal to 0.36 fck b into xu, and what is t1? 0.87 fi is the stress into ast1, right? So you know the I think you know the lever arm. So lever arm is will be d minus 0.42 xu. So this is a lever arm. Similarly, coming to the second figure, so if you see here, so this first figure, this is for mu limit for a balance section, and this is for additional movement. Okay, so here c2 is, how you will get the c2? It is a force in a compression steel, right? So you need the stress in compression steel. So fsc represents stress in compression steel multiplied by area in compression steel, area of compression steel. So the fsc into asc will give you the force in compression steel. Okay, remember, understood? Okay, similarly T2 is equal to 0.87 Fi is the stress in tension steel into area of tension steel. So this is AST2. Okay, so what is our lever arm? Lever arm is equal to D minus D dash. So lever arm is the distance between two forces. Okay, so remember this figure, right? So what you have to calculate? Actually, what you have to find out, or what you have to design in doubly reinforced beam section. In WBM reinforced section, as I told you, the depth is restricted, as well as you in the you will be knowing the overall depth and width, okay, as well as the grade of concrete, that is FCK, and the grade of steel you are providing, okay. So all these elements you will know already, and even the span of the beam span also you will be knowing, and supporting width also you will be knowing, okay, and effective cover, everything you'll be knowing. So you have to find out what is the steel in the tension zone, so that is AST. So what is the steel that you have to provide in tension, as well as what is the steel you have to provide in the compression. So you have to find AST and ASC. So these are the things you have to find, or you have to design in WBM reinforced sections. Okay, so I hope you have understood. Now let us go to the problem and we'll see how we can find out. So to find out AST, look here. So AST is equal to AST1 plus AST2. Okay, so AST1 is the steel for a balanced section. AST2 is for additional movement. Okay, similarly you are having ASC, that is a steel in compression. Okay,